Hi, everyone. Thank you for joining us from wherever you are. It's a real pleasure to welcome you to our third freshwater bond series in this webinar series, Freshwater Bond Webinar. My name is Katie Millett, and I'm the Executive Secretary of GeoBond, which is the Group on Earth Observations Biodiversity Observation Network. GeoBond is an international scientific network that brings together scientists, governments, and organizations from around the world and that are dedicated to improving the acquisition, coordination, and delivery of biodiversity information at all levels and across all thematic areas. This Freshwater Bond webinar series is organized by our thematic Freshwater Bond group, and it aims to provide a monthly space where experts and practitioners can come together, share knowledge and exchange ideas, and discuss advances and challenges in freshwater biodiversity monitoring. Today, actually on the call, we have two people representing our freshwater bond leadership. That's Heidi van de Venter and Andy Bruder. Maybe actually, if I'll hand it over to Heidi, she's going to say a few words first about freshwater bond before we get started on today's webinar. So Heidi, do you want to share your screen?
Yes, thanks. Can you confirm that you can see my slide?
Yes, all good.
So hello, everybody, and thanks very much for joining our Freshwater Bond webinar series. One of the aims that I have is to start reaching out and build intercontinental contacts and networks for us. Some of us don't always have the opportunity or time to go to international conferences. While it's absolutely nice to meet people in person, it becomes challenging. And I really think we should build this network for us all to start enriching ourselves with also knowing who the people are and not just reading the papers always. So for me, this topic where we've invited DHI and Torsten to come and present on the Global Wetlands Watch aligns very well with the monitoring and reporting to the Global Biodiversity Framework, Goal A. With Target 1, how do we represent and monitor changes in our freshwater ecosystems? 2, it's about the intervention and reporting by 2030, whether we've got 30% of the extent of each type under restoration. And Target 3 is about, do we have 30% of the extent under protection? And this is such a critical thing to learn that they have built a global wetlands map that represent freshwater biodiversity, and that we need to start engaging with this to see how well can this help each country in reporting to the Global Biodiversity Framework. So again, thank you very much, Torsten, for stepping in and reaching up for the challenge in trying to do this freshwater biodiversity representation of ecosystems. Thanks.
Well, thanks, Heidi. Thanks, Katie. I will share my screen, and if you allow me to share screen here, Heidi, then I will get started.
Yes, struggling to get back to the webinar page.
Here we go.
Stop share.
So I hope you all can see my screen here.
Yes,
today I'll be talking about a new initiative that DHI, UNEP-DHI, and UN Environment Program is behind, Global Wetland Watch. An initiative will be launching later this year, but there's already data out there that can show how we work with these wetlands. So first, I want to give a little bit of background of where I come from. I work with business development and partnerships at DHI. I have a remote sensing and climate science background. But DHI is a water resource management company that has been around for 60 years. We have around 1,100 employees that work with water in all kinds of different aspects. We are known for the MICE software, that is hydrological modeling software, and have a number of offices across the world, but are not sort of owned by shareholders. So we do a lot of research activities, and all the profits and projects we generate go back into doing research around water. We do have a large department, around 40 people working with remote sensing applications to support all the water projects we have around the world. And then we have also an affiliation with UN Environment Program through our UNEP-DHI Centre, a technical center that supports UN Environment Program with water-based projects and knowledge. Since 2015, approximately, we have been leading European Space Agency's activities on mapping wetlands, and this is how we got about talking to UN Environment Program and Google on how we could develop Global Wetland Watch. So I'll jump to that as we speak here. So the Global Wetland Watch is going to be a new system for mapping and monitoring wetland changes. It is a system that is going to be looking at all the benefits and ecosystem services coming out of wetlands and hopefully help to report on these changes in global conventions like the CBD or the UNFCCC and the SDG 666 framework. So a lot of this data will go into global country reporting. But why do we do this? Wetlands, as many of you know, are biodiversity hotspots. We have so many species that depend on wetlands, and they provide a lot of ecosystem services, especially in terms of carbon storage, but also a lot of benefits in terms of water filtration, flood mitigation. A lot of you in the network already know this, so I'll go fast through this. But maybe what you don't know is that wetlands store around 30% of the world's soil carbon. So that's a quarter of all terrestrial carbon. So they are incredibly important, but we are losing them fast. A recent report from the Ramsar Global Wetland Outlook states that around 35% of the global wetland has been lost since 1970. So what is this data gap that we try to address? Right now, there's no consistency in the wetland data that is out there right now. We don't have good maps of the extent and change. We have scattered maps. We have projects across the world that are very good, but there's no sort of consistent global data set out there that has the same kind of classification type, typology type, etc. We need this data for policy making. So if the politicians and the countries don't have this data, they cannot make any changes on the wetlands. And this is one of the main important features why UN Environment Program engage in this is that they want to use this data for policy reporting and management. So we need maps. We don't have we cannot manage, but we cannot maps. And we think that with this Global Wetland Watch, we can provide a consistent, scalable, and open monitoring approach. What I would like to stress here is that our approach is global. It goes down to provide national maps at 10-meter resolution, but we foresee a lot of partnerships and local projects being part of this initiative, since there will be no size fits all for this. So there will be a lot of exciting opportunities to work with these data to improve them even further at national scale. And I'll give examples of that further on as the presentation goes on. So what is the Global Wetland Watch? We'll be utilizing satellite Earth observation in 10-meter resolution, work with a number of different data sources to provide 10-meter resolution global wetland maps. We use the IUCN Global Ecosystem Typology. This is, to our knowledge, the most consistent framework which is globally accepted right now. So we are happy to work with this one. But there are other and many different typologies, and they are national typologies. So this will not fit all needs, but it will be an excellent starting point for discussion around wetlands in the countries. We have initiated this with a technical background over the last couple of years. What we are now starting to do is to reach out to partners to collaborate with institutions and NGOs to develop the science that's needed for this, and then hopefully with the help of UN Environment Program and partners to get that buy-in from the countries so they can start adopting the data and use the data to create impact. The launching in December 2026, there will be a launch event on that, and you will all be informed about the date for this. This will be open and free data coming out of this, and we foresee to make a webinar series around how to use data in the beginning of 2027. But we already have preview data out there so people can start getting familiar with the data. I will show a link to this data platform later in the presentation. As I said, DHI is the technical science lead of this. We have experience in mapping wetlands from the European Space Agency programs we have been leading. We also have a lot of IT knowledge from DHI in terms of how to develop a platform. But we also need the UN Environment Program for how to get impact and create an uptake from the countries. And then we've been luckily supported by Google in terms of their program for the global goals to develop the technology behind this. And we have received a lot of compute and storage from the Google Earth Engine team to develop this. So wetlands are very complex. I just want to stress this because it also tells you what challenge we are at right now. They're very different. They are across very many different ecosystems. The water regimes keep changing. You can have a wetland that's a wetland for a couple of years, then it dries out, it comes back again. So there are very many different extent changes, dynamic changes, ecosystem changes, tropical wetlands, high Arctic North wetland ecosystems. And we need to map all this, and this is a real difficult task also. So you have different geologies, different land use, and then you have all kinds of different vegetations that can cover this. You have forests covering wetlands, as I'll show you later on also. And then again, as I said, the typologies are very different. There's the Ramsar definitions, there's the IUCN GET definitions, and many national wetland classifications for local and regional ecosystems, wetland ecosystems. So this makes it quite difficult for us to map all this. But the typology we have chosen is the IUCN GET. Here you see the number of classes that we have to address and the challenge in this also. So we have the coastal ecosystems. There are some shoreline biomes, rocky shorelines, muddy shorelines, and just to give you an example, and then you have the tidal regimes where you have the salt marshes and intertidal forests, etc. And then you have the surface water on inland with rivers and streams that are also classified by the system. We also need to cover rivers and streams. And then you have reservoirs, sort of the man-made artificial wetlands and aqua farms, etc. And then you have the forested wetlands, which are really difficult also, marshes, flooded forest, etc., and peat forests. And as you'll notice, peat is of course a very important wetland system also, but this is not directly covered by the IUCN classes as it is, but only partly covered by the definitions also. So this is something that we have to tackle in partnership with knowledgeable peat expert institutions, and we look forward to do this. Just to show you what do we then need to do, I showed you here the different classes from the IUCN. You have the coastal typologies, the inland and the surface water typologies here. And then you need to tackle that from an EO remote sensing perspective, looking from above. And the way we do that is sort of look at the wetland characteristics in terms of canopy height, temperature, terrain, and surface water frequency. And then we combine that with machine learning to get the different classifications based on these ecosystem functions, so to say. And we, of course, very much depend on time series analysis because of the dynamic nature of wetlands. So I'll give you an example here. So we are using both optical and radar satellites to map these 20 wetland classes. And we need time series analysis to look at this. If we only look at this in one point of time, then we would just see a river meandering here, as I shown on the picture here. This is a picture from the Amazon basin. If you then start using radar data, you'll see how this changes over time. The white pattern you see in the background is actually reflections of the radar signal from water beneath the tree canopy. So this tells you that there's a sort of inundation regime where the flood goes over and spreads into the forest. And this is the kind of things that we can do now with a combination of time series analysis and radar data. Here you see also the same thing, just analyzed with some of the techniques we have. Time series analysis showing you some sort of a frequency map of how often a certain pixel is flooded. So we put that into an AI engine to derive a classification of this area, flooded forest here, that then corresponds to the corresponding IUCN legend. Here you'll see that that becomes classified as a permanent marsh, seasonal marsh, forested wetland, lakes and rivers. And this is the kind of information we need to convey to countries and governments, and you can immediately see the benefits of this in terms of deforestation, biodiversity, and then the value these flooded forests bring locally. So this is what we look forward to go in dialogue with you all about. Let me see here. So how do we do it? Very simply, we take EO data, what I've showed you, a number of EO data. We need labels. I'll get back to that. We put that into a machine learning, and then we get this classification out. That's a simplified approach to how we do this. This is a standard way of working with the remote sensing data. And there's, as such, not so much novelty in this. The novelty is doing this at a global scale and getting it right with all these different classes, which means a lot of different workflows and a lot of different ways to look at these data with different labels also. And labels is the issue here. So how to get harmonized data labels globally. This is right now the challenge, and we are extremely open about this, that we don't have labels from certain regions. We don't have from certain regions in Africa or Russia or Asia, but we do have a lot of good labels from other regions, and we want to work with these labels over time and improve the system. And this is where the good thing about AI comes in, that if you manage to create a user base and expert knowledge on the use of these data, we will collect those feedbacks on the different wetland ecosystems, and then over time, with the help of AI, improve not only for that region but also in other regions that are similar to where we then can collect label data also. So label data, that could be examples of surface water, canopy height, vegetation, and topography, just to clarify that. So what comes out of all this? Here I've given you an example of the most important feature that we want to develop globally, and it gives you an idea on the scale also. 10-meter resolution is quite detailed also. So what you see is the classification legend and what we aim to achieve globally in this IUCN wetland typology. But as part of developing this, we will also need a number of different other data sets that we will give out for free. One example is the intertidal frequency. We analyze weekly to monthly data and then compute over a time series going from 2017 to 2025, 26 now. We have analyzed these data to come up with how often is a certain coastal ecosystem flooded and when is it not flooded. So that kind of data we will be giving out also, which can be used by the coastal community frequency. These time series coefficients I showed you also, they can be used by researchers to analyze certain regions if you know how to work with these time series coefficients. So these are very important and valuable time series components also for analyzing special ecosystems also. The surface water dynamics, this is one of the most sort of mature side products, we can call them. We developed this over almost a 10-year period now, and this will be an extremely helpful product for many different purposes also. It will tell you the certain frequency of when an area or region is flooded. And we already in DHI have found different uses of this in different water projects as sort of a side benefit coming from these Global Wetland Watch. And as I said, all this will be available globally going forward in 2026. There's also a topography index called HAND, which is the height above the nearest drainage axis, which tells you how does the water flow and where will the water flow to. So I think this is a product that can benefit certain researchers, institutions also, and we are curious to hear how NGOs, environmental ministries, etc., can work with these kinds of data. So all these are examples of what we will be launching for available for download in 2026. And as I will also state, and there will be disclaimers on this, there will be certain regions that are better mapped than others, but we are very open about that and welcome a discussion around the data in different regions, and especially welcome experts who want to help us improve the methodology in certain regions also. So I'll give you an example of what a use case could be working with these wetland data. So you have a lot of migratory species also that are at risk also. Some of them belong in shoreline or artificial wetlands that can be coastal systems. And what we want to do is sort of illustrate how these kind of data can help create awareness around certain species that are at risk of climate change destroying their habitats, etc. So here's an example of an ephemeral lake that's being filled by the Okavango Delta. What our system shows you is when was this, how often is this certain pixel being flooded, and when does this happen? And we can then get time series out of this. So we can analyze when is the water in the basin often, and that information, if you give that to certain ornithologists or NGOs or governments, they might be able to create certain policy acts or use this information to create good changes in those ecosystems also. So this is what we kind of example of what we want to work with. Here's an example of a migratory bird species that's depending on coastal ecosystems also. And here you'll see the migration pattern of that to the right also. This bird is endangered. It's depending on intertidal wetlands. And what we can see is that the population has been in decline. So what's important for this is that the breeding grounds of these birds keep being breeding grounds, and you inform governments around these breeding grounds and can document what happens to these breeding grounds if you don't actually take care of these environments. So here's a pristine environment in Australia where you see the tidal changes and you see that there's a good habitat for this bird also. But you also see a different example here from a coastal environment that is a breeding ground for this animal, but that has changed dramatically with infrastructure building and changes in the whole environment here. So I think this is the kind of information we want to relay also. Here's another example from the Wadden Sea close to where I am, which shows you the frequency of, again, of the tides and which areas are flooded also. Finally, the typology itself also. Here's an example from Uganda, where we have classified the whole country as part of our pilot activities also. We see there are certain lagoons stepping out. There are certain ecosystems that are covered here also. But we need more dialogue with the country on the accuracy and the validation of all this, but it looks very promising. I have some colleagues working in international development on projects in Uganda, and they could use some of this data to see certain flooding events in certain areas of the country that have not been documented before, and that was helpful for them. But this is the kind of accuracy that we'll be achieving here. I urge you to have a look at this web address, map.globalwetlandwatch.org. If you go to globalwetlandwatch.org, you can find the link there also. This is our preview portal. Since this is a webinar, I was thinking about showcasing this, but that always go wrong when you are doing that in a webinar. So I decided to just keep the link here and let you know that you can access and preview some data from full Africa and full South America to have a look at the different data also. And then we have that period from leading to the global launch where we are trying to reach out to partner organizations to see if we can develop projects together, etc. And this I also urge you to get back to me with ideas on how to work with these data and needs. And also, if you're a wetland expert, you might see a certain area is mapped wrong. So we are very open to get those feedback and try to work with that in the future also. We are also working with the GeoWetland initiative closely and look forward to learn from a lot of the initiatives that's taking part of GeoWetland also, and are looking forward to collaborate with ESA on this going forward also. So we do have a number of partner organizations. Ramsar we are also working closely with or look forward to work more closely with. So a lot of good institutions is curious to see what can we produce. We are curious to learn from these institutions also. So all exciting times ahead. The future work streams, I'm almost done with my presentation. I just wanted to show you what is it that we need to do in the future. We need to develop more on the system itself, better dashboards, to improve some of the remote sensing, hydrodynamics and vegetation change. And then especially the whole concept of ecosystem wetland condition is a complicated and difficult one, which nobody really has a real good answer. Is can you see degradation in wetland ecosystems? And in that case, if you can, then how would you characterize that from an EO perspective or Earth observation perspective? We also have a number of different work streams where we are engaging different partners, and this will be some of you, hope. We would like to, over time, in next 5-6 years, develop biodiversity links to some of these data we have. We want to have a work stream on the carbon fluxes. There we are collaborating with Global Wetland Centre, something that DHI is also involved with. A university funded a 6-year research project on greenhouse gas emissions also. And then there's something around the water management aspects. How can these data be used in taking decisions on water resource management? And then there's a whole outlook policy track in terms of getting these data used by governments. So this is what we want to set out to do. We are supporting some of the big agendas. And just final slide here on what it is that we are doing. So I urge you to have a look at the web page here and then look out for our launch in the end of 2026, and then reach out to us if you want to work with us on this, and then we'll see what's possible. So I think that's my presentation, and over to you, Heidi, for gathering comments or facilitating.
Oh, thanks so much, Torsten. It's really a fantastic. You've presented more than what you chatted with me last year about. I'm so interested in that intertidal mapping and also the migration of the species. That is really super data that you are generating, and thank you very much for that. My first question to you is a bit of a trick question. I hope it's not too difficult. But I have looked at the classification and of the biomes, palestrine versus lacustrine. And one of the challenges is that sometimes, especially in Africa, I saw lacustrine lakes that are dominated by, large macrophytes, such as your Phragmites australis or Cyprus papyrus. And I always wondered who would be the person that can actually put up the threshold between whether it's lacustrine or palestrine. And are you perhaps considering the use of bathymetry, even if it's maybe derived from the ISAT-2 sensor, in drawing that threshold? Oh, it is actually a lake, even though it's got a coverage of palestrine. Or do we come up with it remains a transitional system and therefore more palestrine and not lacustrine? Do you have any answers to that?
No, that's a nice, complicated question. Thanks, Heidi. But the ISAT is certainly something that we look at. Whether we bring that into, we use it in different aspects to get the lidar heights from space, right? And it's true, it can penetrate into the bottom of the lakes and give some sort of idea on this. Whether that's possible when you have vegetation on top of the river, I couldn't say right here, right now. But I know you're also in dialogue with our technical team, Dan, and he might be able to answer that question much better than I can. But I know it's on our radar to integrate new sources. There's also the SWOT sensor, which might be very interesting to integrate over time. But we haven't got that integrated right now. I don't think we have the ISAT integrated also. And then there's a whole new thing around the embeddings, which is a big thing in our world, which is super complicated multi-sensor data sets that's being offered by different institutions. They basically take climate data and the remote sensing data, and then they merge it into one complicated cube of information.
Oh, right.
And you have time series information in that cube. So what we are doing already now is working with some of these embeddings to see what can you extract from those. And is there some valuable information? And maybe we can use those embeddings to analyze some of the things that you are addressing here.
Okay,
So
I'll take it up with
certainly on
your
our radar.
technical team. I think the other question, or something I was just wondering with your website, does it also, because I'm sometimes a bit of a fanatic that also use iNaturalist, even if I'm in the field, I do the recordings for other teams and not necessarily for my own research. And then I wonder, there's not many people that in any case would walk into a wetland and do iNat sampling there for you for reporting. Now, are you considering, rather than just email responses to the product, to also have like an app where people can take photographs of where they are in the field with the notes of what type of label they think it is and type of wetland and, that level? Because I think that's where the citizen science is still separated from what we do with remote sensing and a top-down approach. or the little bit of bottom-up approach of our science, where do we bring in that citizen science reporting that you can also use?
Yes, this has been on our radar from the beginning, 3 years when we started looking into the design of this because we knew we would not get labeled data from our own teams and from what was out there already. So we had an idea to integrate citizen science in a constrained way where we would engage wetland experts to do that kind of labeling. So we knew that they were sort of expert annotators also, and then feed that into the AI engine again to help not only, as I said, retrain that specific region, but also help train similar regions across the globe also. So that system we haven't got in place now, but we have ideas on how to do that, and we are trying to fundraise for developing such a system as part of the Global Wetland Watch. I think this is where it will take up in terms of science usage and actually really improve the data which is out there over time. We need that. So it's really an important point that you're making.
Thanks so much. I'm back to Katie to,
Yeah, well, this question also was related to, I think, what Connor asked, because if we have a lot of wetland experts on the call or whatever, what sort of procedure should they follow if they want to contribute to this effort that it's maybe not citizen science yet, but they're experts. So is it just still one-on-one engagement?
Yeah, I would say so. I think we have a web mail called info@globalwetlandwatch.org. I think it's a bit dull to mention this email, but I think if you write to that, we have a team looking at those emails, and then we'll respond to that how we can engage and collaborate. Because I don't think we have a clear plan right now for how to do that citizen involvement and how to get those labeled data. But we are developing that in the next 6 months and trying to come up with a plan for how to do that engagement of the community better than what we have right now. So this is certainly on our radar, and we really would like to, yeah, that's the one, thanks. Like to engage with wetland experts, but we need a mechanism or modality for that, or else it becomes just scattered noise. And therefore, we hope to fundraise for this so we can do it systematically.
Yeah, I think the systematic approach would be great, and I'm very glad to hear that you are planning and working on that. I was very privileged to be engaged with the first reviewing of the data, and the one approach that I've used was to do PowerPoint screen slides with comments to the team about this is what, and keep the coordinates in the map. Yes, because sharing a KML or a shapefile doesn't really help that much with the comments. But if people do want to upload and share in a similar fashion, maybe, then a PowerPoint presentation where you have a comparative map or a publication listed could be very helpful, I think, to the technical team that I've also met with. Yeah.
Yeah, and once you say that, I think what I can do from my side is I can talk to the technical team. How would we, until we have a system in place, like to collect this kind of data also? I don't have that knowledge per se, so but I can get back to this community on this, or at least the ones who are interested in this. We can let them know how would the technical team best like to collect this kind of data.
Absolutely, and I think another challenge related to that, I've spoken so much with the species teams in South Africa that compiles all the data and integrate all the data for our national biodiversity assessments. And one of the biggest challenges are giving recognition to all the contribution. And Helen Dallas, I see she's also joining in, and she's been explaining a similar challenge for the freshwater biodiversity information system. So in a similar fashion, I think you may also be challenged by the amount of people that gives you contributions or recognition, is how to maybe compile that in a very long database, but also where data was shared, or maybe where the links to other existing data is in journal publications. So it can be quite overwhelming, I think,
Yeah.
whereas the generation of your data set was already massively impressive. There's very few global data sets that really address the biodiversity of systems. And, I've spoken to you also about the underrepresentation, where we get an idea what types and where are underrepresented before we understand what is the trends that we are analyzing. Are they just for 20% of the wetlands on the planet, or do we have a good representation of 70%? So what you've mentioned earlier was also about identifying the confidence areas, which was really great. But what your team maybe in the long term can also look at is how do we represent the percentage of representativity. So sorry, I'm just throwing you with all the fantasies and ideas that we all have.
No,
But
I
yeah,
think that sounds, yeah, that sounds good. But I do recognize that it's a real big task collecting all these science papers and the information, and those are on the labeling and all that. So I do think if we are to really be very successful, we need some sort of structure around that, and somebody leading this collection of labeled data in a more organized way going forward. So we are very conscious about that.
thanks very much. I don't see any other questions in the chat. So then I'm just going to persist with, oh, there's one from Andy.
Yeah, sorry, Heidi. I wanted to give some relaxation to Torsten with a more simple question that comes out of my brain compared to your brain, Heidi.
Thanks.
No, I was actually following up on something that Heidi raised, which is, the sort of this trade-off. Maybe it's a trade-off. I don't know, but I really liked your approach to link to a global ecosystem typology as a framework, because you want to harmonize and you want to make a global coverage. So you need to have a common system that you can use it. Do you sometimes, based on EO data, find it difficult to categorize, to put a system or a location into this system of categories, right? Which is, they are given, they are somewhat rigid. So with the data that you can integrate into the tool, how often do you find it difficult to allocate it to one of the categories? And would, for instance, this more intense collaboration with local collaborators, ground truthing, help you in putting it into the one or the other?
Yeah. I think there are class ambiguities, I think is it in English, where one class you could actually from a remote sensing perspective not know where to put the boundaries. For instance, the river delta is one issue in the IUCN get text. It doesn't say how long does the delta go in or etc. So the limits and the boundaries for how we classify a certain system. That's sort of an example of what we see in some of the classes, but I still think we're relatively okay with most of the classes. But there are these ambiguities where we simply cannot do it correctly because the class itself, the definition of the class, doesn't lean itself to EO. Another example is peatland, which is sometimes. I mean, there you have the Global Peatland Initiative, and we're looking forward to collaborate with this also. But mapping peat from an EO can be extremely challenging also. Some of this is drained peat, so peat scientists would still classify that as peat, but we don't see any water signal in it, so we would classify that as agriculture, for instance. So how to deal with a wetland that used to be a wetland and is now sort of drained into agriculture and things like this, when they are very important for the carbon release and carbon dynamics, etc. So I think peat is going to be an issue we need partners in collaboration with also. And I see my colleague Anis from MedRed is also there, right? Anis, you deal with these questions also, right? Do you want to come in and
Yeah, thank you, Thorsten, and hello everyone. My name is Anis Gelmami. I'm from the Mediterranean Wetlands Observatory, and yes, I totally agree with what you said. That there are some categories, some classes that are more difficult to define. Basically, for example, we have adopted several years ago a hybrid classification system combining correlate cover with Ramsar definitions. And and here again, we faced some difficulties in defining concretely what are these wetland classes, some wetland classes. For example, you've mentioned the delta. For us, delta is a complex of the different habitats, and it's a system itself. So within a delta, we have coastal marshes, rivers, intertidal marshes, etc. And there are some categories that are not mappable or easy to map using Earth observation data. But yeah, using some other ancillary data that we have added, I see in your presentation, and thanks a lot for your very clear and nice presentation. We have also tried to add additional information like topography, hydrology, some information also about the distance from the coast, etc., in order to have better discrimination and the distinction between these classes. But it doesn't work everywhere, and I would assume that it's also the case for your model and algorithm. Especially when we try to adapt this approach at the global scale. So we need sometimes to take into consideration the local context, which is much more challenging when we have the ambition to produce a map at the global scale. But at the local scale, it could work if we adapt the different criteria and use this data from Earth observation and ancillary data adapted to the local scale. Sometimes it provides very nice results. Yeah, but I confirm that we are facing the same difficulty in mapping wetlands in the Mediterranean basin. And thank you again, Torsten, for the nice presentation.
Before you go off, may I have a follow-up question with you? Because I think, the new technologies of being able to list the probability of different wetland types could be really interesting, where you now talk about the deltas or the floodplains. Is that part of the output thinking? Is that one can predict maybe more than one class, but the likelihood, what is the percentage likelihood per class that can be attributed, so that you don't feel obliged to come down to just one category, but at least then people can respond back to that and say that's what the experts would pick and comment on that map or that part of the map.
Yes, I do confirm that this is another approach that we are also adopting, is to have a probability for each class, a probability of occurrence that would help us not to identify 100% that this habitat or wetland habitat class is there, but there is a range of probability, accepted probability. For example, more than 50, 60, or 70% of probability of occurrence. That would help also the managers or the decision makers to adopt some actions and measures, not on the identified class 100%, but with a very high level of probability of occurrence, which is another approach, probabilistic approach.
Very nice. Thank you very much. And Torsten, then I just want to maybe ask you the last question. I can't remember on your slides that you also show that your team also worked on the wetland probability map.
Yeah, we do. I think that will be released also. So I think that's coming out also.
Yeah, I had a look at some of those data sets, and for me, it was very valuable and very interesting. I compared it for a number of wetlands in South Africa, and the thresholds for that would differ across the landscape. obviously
Okay.
because of the geomorphology or the groundwater contribution of different areas. And I thought it was extremely valuable, that product, but that people can also give your team feedback about what thresholds maybe work in different areas for them. Yeah.
Yeah, and I think the point we are making is that we will provide a global system, but in order for this to work, you need crosswalks into the national typologies and the regional scale that Anis is describing here also. There you need to work with the data even more, and I foresee a lot of exciting projects where the base could be Global Wetland Watch, and then you have a starting point for working with national and regional scale projects also. So this is what we hope will come out of this initiative. A lot of good local, regional wetland projects where the base is the Global Wetland Watch.
Thank you very much. I must say your project is so overwhelming and almost intimidating, but I look at it with absolute respect, and thanks for all the work that your team puts in. Thank you for coming to present to us. And I'm handing back to Katie for closure.
Yes, thanks, Heidi. Thanks so much, Torsten. It's really exciting to see this very, very highly backed and supported project, and I'm really looking forward to the launch later this year. Are there any information that we should look for if everyone's interested to know when it will be, or is there a major event that will showcase it?
Yeah. Well, we are making a plan for that next month. So I think there are two options. It will either be a UN Global Water Conference where we release this, or a sort of a social media event which we will launch this. I also want to say that we have secured some operational funding, so this is not just going to be a project that's dying out. We have operational funding to keep the minimum going for a number of years after the launch, so to say. So that's a good thing. So there will be a consistency in the data sets. But I think watch out for the website, and then if you follow us on LinkedIn, then you will be informed about how we do this launch.
Okay, great. We'll look out for that, and I'm sure the freshwater bond community will stay connected with that. So thank you very much again, Torsten. This is really great. To everyone that's here and that registered, we will share the recording on our YouTube channel devoted to the freshwater bond webinar series. If you're interested in the next topic in April, it's going to be on ethno-biodiversity frameworks. That QR code will take you to the page of the webinar series. And thank you for joining us, everyone, for your questions, and we'll keep the conversation going, and look out for the next webinar through our email and LinkedIn communications. So thanks, everyone, and have a great rest of your day.
Thanks a lot, Torsten. Thanks, everyone.
Thanks. Bye-bye.
Bye.
Bye-bye.